Hello everyone, welcome to lab number 1. In this computer lab, we are going to get you accustomed to RStudio, and I am assuming that you've already downloaded R and RStudio and have installed both. Now, the lab that I'm following is on the website. The address is rtgodwin.com/3040/lab1. I'm running this lab for my graduate class as well, so you can go to rtgodwin.com/7010/lab1 and you'll get the same lab. The lab that I'm referring to is in the top right corner of the screen here. So this lab right here, this is not part of RStudio. This is the computer lab that I'm going through. Now, when you first open up RStudio, it should look something like what is on my screen. And the first thing that you want to do is to open up a script file. So click on File in the top left of your screen. Click File, New File, and RScript. And then you should get something that looks like what I have set up here. So I'm going to hide the computer lab window, and I'm just going to talk about what we're seeing on our screen here. So in the top left we have the script window. That's where you're going to type your commands, your R code. In the bottom left is the console window. This is where output will be displayed. So when we run a command in the script window, the output, the answers, will be displayed in the console window. In the top right we have the environment window. This will show us data sets and variables that are in RStudio's memory. And in the bottom right we have things like plots, so our histograms and our scatter plots will show up in the bottom right window. Now let's take a look at the lab that we're going through today. So the first thing we wanted to do was open RStudio. Hopefully you're able to do that. And the second thing was to create a script file. So that's where we clicked File, New File, RScript, and then we should see these 4 different windows in RStudio. Next we will run a simple command. We're just going to use R as a calculator. So let's try adding 1 and 2 together. So I type 1 plus 2 in the script window, and I'm going to make sure that the cursor is active at the end of the line, and then I just click this Run button here. Click Run, and you should see in the console window that the result 3 has been printed out. So here are some more algebraic operators in R. This is how we would do multiplication, division, and exponentiation. So we tried running 1 plus 2, and we were hopefully able to do that. Alternatively, to run the command, you can highlight what you want to run and then click the Run button. You can also press Control Enter on your keyboard if you're using a PC, or Command plus Return if you're using a Mac. Okay, now we're going to create an object in R. So to create an object, we need to name it and then assign it a value. And note that you can copy and paste code from the lab directly into R. So you can just highlight the code that you want to run, copy, and then I'll go to my script window and I'll paste it. So what's going on here is that we are picking a name for, this is going to be a variable that we're creating, or an object, and then this arrow is assigning that object the value of 3. So if I make sure the cursor is at the end of that line and click Run, then what we should see, and let me just hide this lab window here, what we should see in the top right environment pane is that we've created a value A, or we've created an object called A, and its value is 3. And I'll do the same for the next line of code. I will click Run. There we have it. We've created B. Its value is 5. So we just created a very simple object that's called a scalar. We created that simple object in R. Now I can refer to those objects. So now I could do math to those objects if I wanted to. I could multiply A and B together. So I would type A star and B, and then I'm not going to click the Run button. I'm going to press Control and Enter. We've run the command. The console window, it copies the command that we just ran, and it gives us the answer right here, 15. So that's 3 times 5. Now, last bit in this section is we are going to create an object that is not a scalar, something a little bit more complicated, but not too bad. We're going to create a vector, and I chose the clever name myVector. I will copy and paste this code into the R script, and before I run it, I'll just briefly say what's going on here. So I've chosen the name for my object that I want to create, myVector, using this arrow to assign it some values. Now this arrow, that's the less than sign that is on the comma on the keyboard, and this is the minus sign next. Then I'm using a simple function. So we're going to talk about functions in the next section. This is the combine function. So I use a C to call the function that I want. The function name is C, and then inside of these parentheses, these round brackets, I'm putting all the numbers that I want to combine together, and each one is separated by a comma. So I'm combining 5 numbers, 1, 2, 4, 6, 7. When I run this command, click run, I will hide the lab window. I've created an object called myVector. R is telling me it's a number. It's got 5 positions in it, and these are the values. These are the values of myVector, 1, 2, 4, 6, 7. Okay, now I mentioned functions, so let's explore some simple functions in R. So to call a function in R, we would type the name of the function that we want to call. So a function is just a formula or an algorithm. We type the name of the function that we want to call first, and then what's called the arguments of the function we put in the parentheses. So a generic function name, a generic function we would call by function name, and then inside of the round brackets we put whatever we want to apply the function to. Now there are many functions in R. Here's a few that we'll need for this lab: sum, mean, variance, and summary. And you can probably tell by the names of these functions what they do. Let's try all of these functions on myVector. Well, you know what? You can try them all, but I'm just going to try 2 of them. Okay, so we're going to try these functions on myVector. Let's see how to do that. I type the function that I want to use, sum, and then inside of some brackets, these round brackets or parentheses, I will put in the object that I want to apply the function to. I want to apply it to myVector. When I run that code, R is telling me the sum of all of the numbers inside of myVector. So that is 1 plus 2 plus 4 plus 6 plus 7. Great, it is 20. You know what, I said I'd only do 2, but let's do 3. I'm going to take the mean of myVector. So the mean is actually the sample mean. We're taking the sample mean, or the average, of those 5 numbers. I click run, and here is the answer. That is the sample average of the sample mean of myVector, which is just, again, just a list of numbers. Now finally, I want to use the function summary. Show you this function. So I would type summary, and then in the round brackets, the object. See this little yellow window is popping up, giving you some hints about what you should do. You should give the summary function an object. And the object I want to give it is myVector. Run that command, and what do we have here? What we have is some summary statistics. So it's giving us the mean, the first quartile, median, mean, third quartile, and max of that variable. Now this is a very small variable. There's only n is only equal to 5. But when we apply this function to bigger variables or even to data sets, these summary statistics are going to be more interesting, more meaningful. Okay, next section is logical operators. A logical operator can be used to tell if elements of an object meet a condition. And so when we use a logical operator, we can determine whether something is true or false. Now, why would we want to do this? Well, in a later section, we are going to create subsamples or subsets of our data. To do that, we are going to condition on some values that a variable might take. It's very common in economics to, for example, divide a data set on wage by men and women, or to divide by foreign and domestic, or by geographic location, north, east, south, west. To do that, we will need to use something like what I'm proposing here, is to filter the data using logical operators. So the ones that we will need are greater than, equal to, so that's a double equal sign, less than, greater than or equal to, less than or equal to, and then finally not equal to. So before we start filtering our data and creating subsamples or subsets from the data, let's see what these operators are actually doing. So let's try entering a few commands into R. When I type 8 greater than 4, well, that statement is true. So R should tell me, yes, what I've written is true. Let's try that. Great. 8 is greater than 4. That is true. Now, that's not a very interesting example. Let's try something a little bit more interesting. So now I'm going to ask if the object B is equal to 6. Well, we know that B is equal to 5, so this is a false statement. If I run that command, I get a false. So R has taken a look at the object B, and it has determined that it is not equal to 6. Thank you, R. We could ask it a few more things, but I'm gonna skip right down to the bottom here, or the second last command here, and I'm gonna ask if my vector is greater than 3. Well, my vector consists of 5 numbers, right? It's a vector that contains 5 numbers. So what R is going to do is it's going to check each value in my vector, and it's going to check to see whether each value is greater than 3. I run that command, and I get the values, or sorry, R has checked each value in my vector and has told me whether it's greater than 3 or not. So this one is not, second one is not, third one is, fourth one is, fifth one is. Great. Now, how is this helpful? Well, I could now use this idea to filter my data set to create subsamples or subsets of the data based on conditions of the variables, or based on the variables meeting certain conditions. So if I wanted to work with values in the data set where everything was greater than 3, I could use a command like this to get rid of the low values out of the data set. Now, sometimes we're going to want to combine 2 conditions together in our logical statement. That is what is going on in this command. So this line of code is going to ask which values in my vector are greater than 3 and are less than 7. So I run this command, and it's told me which values are between 3 and 7. The third and the fourth. Very nice. Okay, now let's start working with some real data. So let's load some data into R. Now there's a few ways to do this, but the first thing we need to do is choose a name for our data set. So I'm not very clever. I'm just going to call my data set. I'm going to call it my data, but you could pick any name you wanted to. And the next thing I'll do is I will assign my data a value, and the value I want to assign it is actually an entire data set. It's going to be like a spreadsheet, like you might see in Excel. I'm going to use the read.csv function. So CSV stands for comma separated value. It is one of the most common ways of storing data. If you're using Excel, for example, you could always save your data set as a comma separated value file, and then you could open that file with pretty much any econometrics or statistics program. I will be using the CSV files throughout the course. So I'm using the read.csv command. R is now going to be looking for a CSV file. I need to tell R the location of that file. R can read CSV files directly from the internet. So I'm going to type in the internet address of the file that I want to use, and it is stored on the website. So we're going to go to rtgodwin.com/data/vidsales. This data set is on video game sales. Let's run that command, and now I'm going to hide this tutorial window and just take a look at what's happened up here. So in the top right environment window, you should see a data set appear. It's called My Data, and it is telling us that there are 4,706 observations in that data set, so that's the sample size, that's n, and there are 8 variables in that data set. Now that we have the data set loaded, we should take a look at it. So the first thing you should do is always explore your data, and we can look directly at it in the spreadsheet. We should also plot it, and we should also create some summary statistics to try to figure out what our data set looks like. But the first thing we should do is probably just let's look at it in spreadsheet form. So we're going to click the spreadsheet icon next to the data set to view it. I need to hide this tutorial window again. The spreadsheet icon I'm talking about is right here in the top right of the screen. So here's our data set, My Data, and then you can see this little spreadsheet icon. We click that, then a window in the top left pops up, and it shows us our data as it might appear again in Excel in spreadsheet form. So this is showing all the variables as columns. At the top of the column are the column names, so this is the variable name. And each row is a different unit of analysis. It's a different video game that we're going to analyze. Okay, so our variables are name, the name of the video game. We've got Wii Sports, Super Mario Bros, Mario Kart, very nice games. Then we have the genre of the video game. So this is where the video game is a sports game, a party game, simulation, role playing. We've got a rating for the video game. So E for everyone. We've got some mature games over here. Platform is, there's different platforms that you can play the games on: Wii, NES, Game Boy, PC, Xbox 360. Publisher, so this is who made the game. And then the variables that we're going to really pay attention to in this tutorial are score. So this is critic score. This is the, I'm not sure where exactly this comes from, but there's a few websites that rate video games, IGN and Metacritic, and I think a few others. I'm not sure where exactly this variable is coming from, but it is likely an average of those scores. Okay, and this score goes between 0 and 10, I think, are the possible values. 10 would be the maximum score. And then we also have sales. So this is sales in millions of dollars, and I think these are global sales. Now, this data set is not, I'm not sure that it's super accurate. I can't vouch for the accuracy of the data. This is just a data set to play around with and to just to introduce ourselves to R. So don't take any analyses we do, don't take it seriously. Alright, so now we've looked at our data in spreadsheet form. Let's click this X right here, close down the spreadsheet, and let's see what we should be doing next. We should explore the data. So I'm going to click the blue arrow next to our data set in the top right of our screen, and that's going to give us a little bit of information about the variables in our data set. We're going to see that each variable name is listed along with some info about that variable. So let's take a look at what we have here. I click this little blue arrow next to my data set, and we can toggle We can toggle this information on or off. We've got the name of each variable in the data set, and then we've got some information about those variables. So this CHR is telling us that it's a character string. We have a bunch of character strings in our data set. So they're just words, and we can't really use those variables very easily until we translate them into numbers. So that's something that we may need to do later. But the score variable is a number, so that's like a real number on the real line, or sorry, a continuous number on the real line. Same with sales, that's a number. And year is an integer, so it's a whole number. Now, we can use the character variables to create dummy variables, but we'll talk more about this a bit later. For now, let's calculate the summary statistics for all the variables. So I'm going to type in summary. I'm going to use that summary command again, but I'm going to apply it as an object. I'm going to give it the whole data set. So I'm going to apply the summary command to the entire data set. And R has calculated the summary statistics for each variable in the data set. Now, most of the variables are actually character strings, so it's telling me that these are characters, these are just words. There's not a lot of math that R can do to those variables except tell me the length. But when we get to the continuous variables, we're getting, again, the minimum, first quartile, the median, mean, third quartile, and max. What is missing and what we might want to look at is the variance. So let's try taking the sample variance of one of the variables in the data set, sales. We use a variance function, and in the brackets I'm going to give it the variable that I want, and we're going to see something new here that is important. I want to take the variance of, for example, the sales variable, the global sales in millions of dollars. But instead of typing just sales, which would give me an error, in fact, let's try it. So if I try to take the variance of sales, if I click run, I get an error. It says that the object sales is not found. That is because sales is contained within the MyData data set. So I need to tell R the location of that variable. That variable is inside of an object. So I need to type MyData $, and then sales. So that's how we can locate one object within another, in most cases, is using that $. Now when I run that command, I will get an answer. The variance of sales is 7.6. What I really want to explore is the relationship between sales and score. So I anticipate that video games that score better from the critics should sell more. Now the very first way we can think about the relationship between two variables should probably be correlation. Here I'm going to take the correlation between sales and score. I have asked for the correlation function, and then inside of the brackets, the round brackets, I need to give the correlation function two variables. I'm going to separate those two variables by a comma. When we have multiple arguments in a function, those arguments are usually separated by a comma. So here we have the first variable, sales, and I need to locate that variable inside of the MyData dataset. And the second variable that I want to look at is score. That is also in the MyData dataset. I run this command, and I find out that the correlation is 0.26. That is telling us that there is some positive linear association between these two variables. It's telling us that games that score higher by critics tend to sell more. Now let's return to this idea of subsampling. We're going to use the subset function together with logical operators in order to create subsamples from our data, and this is done very commonly. Often we don't want to use the entire data set. We want to focus in on a particular group. Now, Nintendo is my favorite publisher, so let's look at the critics scores of Nintendo games compared to the critics scores from all other publishers. So I'm going to use the subset function. I'm going to use the subset function inside of the mean function. So this may get a little bit complicated, but let's take it easy here. So I'm going to ask for a subset of this variable, score. So when I use the subset command, the first thing I need to put in to the command is the variable or the data set from which I'm going to take the subset. So I'm going to give it the score variable, and then I'm going to narrow down the score variable from there. So the first thing I give the subset command, again, I give it the overall data set or the overall variable that I want to extract a subset from. And then the next argument in the function is the condition that I'm going to use to create the subsample. So the condition is that I want this variable, publisher, to be equal to Nintendo. So you know what, let's just try running the code inside of the mean function, and let's see what we get. So I'm only going to highlight the code that I want to run. I don't want to run the mean yet. I want to show you what happens when I run this subset. So when I run this subset command, R has extracted the scores for only the Nintendo games. And look, there were 4,706 games in our overall data set. Now we're only getting about 425. So these are all the scores of the data set. These are all the scores of the video games, the Nintendo video games in the data set. And then I'm just going to apply the mean to all of those numbers. So I'm going to take the sample average of all of those numbers. Let's try running that code. And we find out that the mean score for Nintendo games is about 7.8. So I created a subset that was, I chose only certain values of the variable score based on a condition. And that condition was that the publisher should be equal to this word, Nintendo. Now I'm going to do the same thing, but I'm going to do it for not Nintendo games. So I want to do it for all other games. So I'm just going to copy the same command, except I'm going to change this to not equal to. So I type exclamation and equal sign, so that's checking that all the games that I want to use are not Nintendo games, and I'll take the mean of all of those scores. So when I run that command, I find out that the mean score for all other games from all other publishers is lower. It's 7.2. In that example, we created a subset of just a variable, but we can create a subset of the entire data set. So that's probably more commonly done. And let's try it out. So I'm going to skip this command. I'm going to skip this example. I'll let you try that on your own. Let's instead find all the video games that have received a perfect score of 10. So I'm going to ask for a subset of the MyData dataset. So that's going to be all the variables in the spreadsheet. All the columns are going to be in the subset, but only certain rows will be included in the dataset. And those rows will be selected by this condition, where score is exactly equal to 10. Let's try running that, and then R is just going to print out the results. It's just going to print out the data set that matches that condition. Now it's kind of a little squished together in my window, but here are the name of those video games that matched the perfect score of 10. So we've got Super Mario Bros., very good game. Minecraft, sure. Legend of Zelda, sure, why not? But notice that we have, for each video game that matches that condition of a perfect score, we have all of the variables in the data set: name, genre, rating, platform, publisher, score. Those are all 10s, we can see that right there. Sales and year, those are all the variables in the data set. Finally, let's create and save a new data set using the subset command. And this is probably the most common way to work with this subset function. So I'm going to start by naming my data set vid2, and I'm going to create it from a subset of the overall data set, all the video games, my data. And I want to work with, now and for the rest of the lab, I want to work with video games that have sold more than $2 million, or 2 million or more. So the condition I'm going to give it is that the variable sales should be greater than or equal to 2 million. So again, in the subset command, I give the overall data set, and then the next one is going to, the next argument in the function is going to select the rows based on a condition. And the condition I want to use this time is that the sales should be greater than or equal to 2. When I run this command, now this subset that I create is going to be assigned to a new object that I have named vid2. Run this command and take a look at the top right of your window, the top right of your screen, where the environment window is. You should see that you now have a new data set called vid2, and notice that it is smaller, 689 observations instead of 4,000. Still 8 variables. Let's click on the spreadsheet icon, take a look at what we have here. What I want to verify in particular is that the sales of each video game in this data set is greater than or equal to 2 million. So if I scroll down, I find out that yes, it appears that every game in the data set has sold at least $2 million. Okay, close that down. Open up the lab again, and next we are going to start visualizing the data. Let's create a histogram and a scatter plot. So to create a histogram, we use the hist command, and the only thing we need to give the histogram function is the variable that we want to plot a histogram for. So let's take a look at the histogram for score. And I'm going to use the subsample, the subset that I created, the vid2 data set that contains games that have sold at least $2 million. So I want to look at the score variable for this data set. I type hist vid2 score and run that command. Now you are going to get a plot pop up in the bottom right window. So here's our histogram. Let's make this a little bit bigger. Now you should know what a histogram does from your previous statistics courses, but just briefly, it's binning the data. It's telling us visually how many values fall between, for example, in this right bar, how many values fall between 9.5 and 10, and the height is measuring, or the height is telling us the number of values that do fall in that range. So this gives us an idea of the distribution of the variable. We see that there's a lot of action above 8. A lot of games are rated above 8, and it's kind of a skewed distribution. So let's bring back my face here and the lab. So we've now created a histogram, and I will mention that you can call options for this histogram command. So we can do all kinds of things to it. The main things we should do is give it an overall label. So all of these options are separated by a comma in the histogram command. Main is the main title of the histogram. I can give it a name here. I can label the x-axis. I can change the number of breaks in the histogram. I'll just show you what that looks like in the lab page. So here we've changed the number of breaks to 10, and it's kind of clumping the data together too much. So usually R is pretty good at automatically picking the right number of breaks or the right number of bins for your histogram, but you may want to fool around with it. And just be aware, in all of these plot commands, all of these graphical commands, there's a ton of options that you can choose. You can change the color and all kinds of things. Now for your own work and for these assignments, you should at the very least give the histogram a name, or give it a title, and you should label the axes as well. Now let's move on to the scatter plot. So the scatter plot is a very powerful and commonly used graphical tool for visualizing the relationship between two variables. Now, as I said, I'm interested in the relationship between the score that the video game receives and the amount that it sells. So let's begin by making a scatter plot of these two variables. And I'm going to include some of the extra options in here to make the scatter plot look a little bit nicer right off the bat. So we use the plot command, or the plot function, and then inside the inside the round brackets, the first two things we need to give it are the two variables that we want to plot. Now I'm gonna type the command out here to show you something. So if I type plot See, this helpful little box shows up, this yellow box, and it's telling me that I want to put the variable on the x-axis first and the variable on the y-axis second. So whatever variable you want on the x-axis, you put it first. So I want score on the x-axis, so there it is first, and then sales is going to be on the y-axis. I'm giving the scatterplot a title. This is critic scores and video game sales, and then I've also labeled the x and the y axes. So let's run this command, and I'm going to have to hide my face again. Goodbye, Ryan. Here is a simple scatter plot here. Now, it doesn't look super nice because there's a lot of data clumped in the bottom right, so it's a little bit difficult to see what's going on. But we are certainly seeing that there is some kind of it looks like there's some kind of a positive relationship between sales and score. So this is reflecting the positive correlation that we determined before. Next, I want to do something that can be an extremely useful and powerful visual aid, is to add color to the plot, but more than that is to pick the color of each data point based on a condition. So let's see how to add color to the plot. I'm going to use a new option that I haven't showed you yet in the plot command. So I'm going to skip labeling it, and I'm going to skip giving it a title and labeling the x-axis. I'm just going to show you the color command. So 3 is going to correspond to green. I could also type the word green in here, but actually I want to stick with the numbers. And if you just Google plot color, you'll see a table that tells you what all the colors are by number. And also PCH, I forget what PCH stands for, but it's controls the style of each data point. It controls the style of the dot. The default is 1 is a hollow circle, which we already have in our plot, and 16 is going to be a filled in circle. But there's all kinds of shapes. You can get squares and triangles and whatnot. So I'm going to run this command, and I'm not gonna get rid of my face this time, but you can kind of see in the scatter plot underneath that the dots are now filled in and they are green. But what I really want to do with this color command is I want to use it to control the color of each data point based on a condition, based on the value of a variable. So this is, as I said, this can be very useful, very powerful. When you do this, you can find patterns in the data that you wouldn't be aware of otherwise. So you may find out that the wages of men follow a certain pattern different from the wages of women, and you might only see this once you actually color code each points by men and women. So we are going to create a new variable in our data set that is going to correspond to the color that we want for each data point. Now, this is not the best way to do this. So what I am showing you in the lab, this is not the best way of doing it, but it is the simplest way given what limited code we have seen thus far. So the first thing to do is to create a new variable in our data set. And I'm going to call the variable G. This is short for genre. So I'm gonna color code each data point by the genre of the video game. I want a different color for role-playing games, a different color for platform games, and so on. So I'm going to start by just creating a variable that consists just of ones. Let's run this command and let's see what happens to our data set. And let me first minimize this window, and I want to go to the environment pane, and I want you to keep an eye on this vid2 data set. See that it's got 8 variables in there. When I run this command, we're going to see that 8 turn into a 9. Run the command, there we go, we've got 9 variables. We've added a new variable to the data set. Click the spreadsheet icon. Let's go over to the right. There's our new variable G. It's just a bunch of ones. It's just a column of ones. Now I'm going to change those values based on some condition using a different variable. And that variable, I could use any variable, but I just for this example, let's use genre. So I'm going to change this G number to a different number based on whether it's sports, and then yet a different number if the video game is platform. Let's see how to do that. I'm just going to copy all this code. Copy all this code and discuss it a little bit. Alright, so now don't worry too much about this because we're not really going to use this again. But these square brackets here, these can be used to locate a row in the variable. So I'm going to ask R to assign a value of 2. So I'm going to overwrite the ones that are already in that variable. I'm going to overwrite it with a 2 only if the genre is action, if it's an action game. So I'll change that 1 to a 2 if this variable, genre, is equal to the word action. And what's really happening here is that I'm indexing. I'm taking this entire variable and I'm only picking out the rows. That's where the square brackets come in. The square brackets are gonna choose certain rows. I'm choosing only the rows that meet this condition, and then I'm going to change those values to a 2. And likewise, if the game is sports, I'm going to give it a different number, a 3. If it's a shooter, 7, etc. So let's run this command, or let's run these lines of code, and then let's go to our spreadsheet and verify that the command has done what we think it's done. So the first game is a sports game. It gets the number 3 for G. The second game is a platform. It gets the number 5. Here we've got another platform. It also receives a 5. So I'm just creating a variable that is really coding. It's turning that character variable, genre, it's turning that into a numerical variable. It's coding it with numbers. And then I'm going to use those numbers to pick the colors of each data point. So instead of picking the color of all the data points, in this command, which contains a lot, but the thing I want you to focus on is the color. In this command, I'm going to pick the color of each data point based on this G variable that I've created. So each data point can have a different color, and the color is determined by a variable. Run this command, and we will see a whole mess of colors. Goodbye, Ryan. Here are all the data points coded by color. Now, realistically, this is too many colors. This is too many colors to be useful. It's just an example. But what it can do is it can reveal patterns in the data set. So you may see that certain values are clumped together by color, and that can tell you something that can be insightful, or can lead to insight. Now, just adding colors isn't that useful. You need to know what the colors mean, of course. So, come back, Ryan. Let's see what the colors mean. Well, the colors are going to be described using a legend. We need to use the legend command after we create a plot. So I'm not going to go through this too much, but in the legend command, we can choose the location of the legend. We're going to need to provide words for the legend along with the colors that correspond to those words. So when I chose action to be equal to 2, in the legend I need to tell that the action is colored by 2, which I think is blue. I'm not sure. But we'll find out once we run that legend. So let's click run, and action is coded with a red. So let's get rid of my face again. Alright, so we have the legend, and it actually got kind of messed up because I stretched the window after I ran the command. So let me rerun the command. Let me rerun both commands. So I'm going to plot and run the legend again. There we go. So now we know what each data point, what the color of each data point actually means. Okay, now after we've created our graphic, we can export it. So click the export button right here, and we have several options. We can save it as an image, we could save it as a PDF, or we can copy to clipboard. And let's check out this copy to clipboard. So when we do this, we can control the dimensions of the image. We can change the width and the height here. So if you want it to match a standard height, like 600 by 450, then we could change it here. We can export it as a meta file, and this is the way to go to maintain the best quality. So if you export it as a meta file and then paste that into Word or whatever word processing program you're using, you're going to maintain the highest quality. If I click copy plot, that'll just copy it to the clipboard, and then I can paste it wherever I want to. Okay, now the last thing we're going to do is to, oh, I'm sorry you can't see what I'm looking at here. So we just tried importing your work into Word. We use the export button there, and we can save it as an image or whatever. The last thing we want to do is a simple least squares regression. We're going to do a lot more of this later on in the course. Well, the question I'm going to ask here that can be answered through this least squares regression is, what is the average increase in sales, video game sales, associated with an increase in score? So imagine that we were creating a video game and we thought, well, should I spend extra time to make it a good video game and increase the score by, say, 1 on average? What would be the benefit of doing that? Well, we could look at the history of the sales of video games, and we could see if a higher score is associated with higher sales, and we could try to quantify that increase in sales due to an increase in score. So we're looking for, say, the marginal effect of score, a change in score on the sales of the video game. We'll do this by estimating a simple linear regression model. We use the LM function in order to do this. So LM stands for linear model. Let us try it. Let's see what happens. So I'm using the LM function, and inside the brackets, well, the first thing it's going to ask for is a formula. It wants the formula of the equation that we want to estimate. And I don't want to get too much into the model that we're estimating right now. Just go with it. So we are going to have sales on the left-hand side. This is going to be the dependent variable. And instead of an equal sign, I'm going to write a tilde, and then I'm going to put score. And now I need to tell the LM command where to find those variables. So at least I need to provide the option of where to find the data. So I'm going to type data equals, and I want to use the vid2 dataset. I could also do this for the my data dataset. I'd be using a different dataset. So let's run that command, and there we have it. Those are the results of our first least squares regression in this course. We are getting an intercept, and this is the slope on the score variable. So what it turns out what R has done is it has fit a straight line. It has drawn a straight line through the scatter plot of data that we've seen, and this is the intercept for that line, and this is the slope for that line. And what that slope is telling us is that if the score of the video game is increased by 1, then on average that video game sells $0.9 million more. So that could be interpreted as, loosely, the benefit in terms of sales of increasing the score, the critic score of the game, by 1. Alright, and very last thing is you can save your script file. So make sure that the cursor is active somewhere in this top left window. You have to click somewhere in there, make sure the cursor is in there, and then go to File, click File in the top left menu, and save. And I said that was the very last thing, but one very last thing is your workspace may get cluttered up. Let me get rid of this lab window. So all of the stuff in the environment that is floating around here, you may just want to get rid of it and start over. To do that, click this little sweep icon here, this little broom here. If you click that, it'll give you a warning. Do you want to clear the environment? Yes. Now everything is gone. The script file is still here, right? So if I just highlight everything and run it, I'm going to be right back to where it was a second ago. Okay, well, thanks very much for watching, and I hope that this was helpful. Goodbye.